everyone, welcome to this newest video. My name is Johan, and together with me is again our very special guest Filip Verloy from Rubrik. He's field CTO at Rubrik, and in the last video we talked about the technology that Rubrik offers and how the whole architecture looks like. And today we're going to talk about the integration with the VMware software-defined data center, right?
Right. Yep.
So what would you like to explain to us?
So, if you take a look in a general session or in a general sense of how we integrate with VMware. So, if you look at the solution that we have, so we call it CDM or Cloud Data Management. It's a software fabric, but it's typically delivered on a hardware box. So, if you then look at the source that we want to protect, in this case, let's say it's an ESXi server with a bunch of virtual machines on top of it. And then you have your vCenter server, of course, which is managing it. So the idea is that on the front end and on the back end, we always want to do API-based integration. So we want to consume the APIs of the third-party vendors as much as possible. So in the case of VMware, what we do is we talk to the vCenter server. So in this case, we use VMware's SDK based on the virtual disk development kit, and then we integrate natively using VADP. So we do VMware's API for data protection to actually snap a virtual machine based on standard VMware snapshot technology.
Right. So this allows you to, for instance, use change block tracking, right?
Absolutely. Yeah.
Right.
So we snap a VM, then the snapshot of that virtual machine is transferred to our solution, if you will. And then for each consecutive snapshot that we do an incremental forever for all sources. And as you say, the incremental forever for VMware is based on CBT. Yeah. So those incremental snapshots, they all get put on our storage layer, if you will, on CDM. And then we do deduplication. But we do deduplication based on application intelligence. So what we do is we query the vCenter, and then we can see which operating system a particular virtual machine is using.
Right.
So based on that, we can say, okay, this is a Windows machine, this is a Windows machine, this is a Linux machine. We would take those two together, assuming, let's say, it's the same Windows Server version, and that already tells us that the operating system layer is going to be similar between those two. So that means that we don't have to waste a bunch of dedupe cycles to try and dedupe those two things, because we know that's the same data is sitting in there. So we sort of group similar based operating systems together. We ingest them onto our appliance, and then we store them as capacity efficient as possible, if you will. And then what we do is you set, based on an SLA, you sort of define how long the data should be on Rubrik's appliance. So the way that looks like is we present a big storage pool based on direct attached disks on the system to CDM itself. So the actual data is sitting on this big storage pool. And then based on the SLA definition that you have given us, which has an RPO and RTO value, we keep the data for a certain amount of time on the Rubrik itself.
Right.
But then typically what we do is we have the ability to connect, again, using standard API integration with a third-party storage layer. So this could be the public cloud.
Like an Amazon S3 bucket or?
Yeah.
Right.
So it could be Amazon S3, it could be Azure Blob Storage.
Right.
It could be GCP, whatever the customer wants to use, really. It could also be on-prem object storage, so anything that has an S3 API in front of it. It could be NFS, or God forbid, it could be tape. So that is possible as well.
Does that still exist?
In some cases, yeah.
Right.
So that's totally fine. So the idea is then you can consider Rubrik more as a recovery cache than as the final destination of the backup data, if you will. So and the reason that we have a near zero RTO, so in terms of recovery time, we can restore virtual machines, but also physical workloads in a matter of seconds, typically. So the way that we do that is we have these spinning disks, but we also have SSD in the cluster. And we use the SSD capability to actually create a copy of that backed up virtual machine and present that copy of that virtual machine back to the ESXi host for restore.
Wow.
So instead of, let's say you have an NFS data store, or whatever data store you have sitting behind your ESXi server, instead of streaming it back to the primary data store, so we opt to put that virtual machine back on the SSD or on the SSD of the Rubrik cluster. So the idea is then we can do this for, let's say, a default virtual machine of a couple of 100 gigabytes. We can do this in a matter of seconds.
Wow.
So, and then the idea is that we would present dynamically, we would present a data store to an ESXi host of your choice. So the ESXi host would still give us CPU and memory resources, but Rubrik would provide a temporary NFS data store, which will host the restored copy, and then an end user can actually use that virtual machine that's now being powered from our NFS data store in production.
Right. And use storage vMotion, for instance, to migrate the VM back to the primary storage.
Yeah, absolutely. So if you look at a typical cluster, which consists of a minimum of 4 nodes, so each node has this SSD inside of it as well. Then what we say is that each 2U appliance roughly will give you 30,000 IOPS in a 4K block 50/50 read-write capacity. So the idea is the system has a lot of IOPS available to do these instant recoveries or live mounts, as we call them. And then, as you say, maybe after working hours, when it's a bit, when the systems are under a bit less stress, the production systems, you simply initiate a storage vMotion, and you do that from the Rubrik interface itself. And then that storage vMotion will put that virtual machine from our NFS data store back into the production NFS data store. And the customer can continue running that way.
That's pretty cool. So is that data store, is that created on a per VM basis, or is one general data store being created where all those possible recoverable VMs are living on?
That's a good point. So actually we create that NFS data store dynamically. So if you go into the vSphere web client and you sort of right click on where is that VM actually living on, you will see this random string of numbers pointing to our NFS data store. So the idea is you select a random ESXi host, we create a temporary NFS data store, and the idea is one VM or a number of virtual machines, depending on how many you want to live mount simultaneously, live on that NFS data store, and no other ESXi host has access.
Wow! So from a, for instance, a multi-tenancy perspective, it's fully multi-tenant, right?
Right. Yeah. Yeah.
Oh, that's really cool.
Yeah.
Cool. So you already drew a couple of public cloud offers as probably a cold storage, right? So cold VMs, cold blocks that are being exported to there. Can remain there, but is there something smart you could do from a public cloud perspective as well?
Sure. So if you think about it, let's say a traditional backup and restore solution, typically what you do is you backup data and you don't use that data until you need it for restore. So it's essentially cold data sitting there waiting for the worst day of your life to be restored. So what we did is we sort of took a step back and tried to figure out, is there anything more we can actually do with that backup data that's sitting there not being used? So one of the things that we can do is, depending on the SLA, at a certain point in time, the data flows to a public cloud storage bucket, S3, blob storage, whatever you want. And then what we can do is, we have this concept of, particularly for test and development purposes, we can take a backup copy of a VMware-based virtual machine and we can temporarily spin that up as another instance in the public cloud.
Right.
So for example, the idea would be, let's say this virtual machine is sitting on our system. We have archived it, as we call it, into the public cloud, but it shows up in the public cloud as a VMware snapshot. So it's sitting in this VMware container, right? So what we can do is we can read the configuration file of that VMware container. So we look into the VMX file, and that tells us things like how many virtual CPUs are configured for that particular virtual machine, how much memory is configured for that particular virtual machine. And we use this to translate that into a t-shirt size for the public cloud. So if we want to do, if this matches with a tiny instance or a medium instance or a large instance, whatever you have. So this is information that we take to then migrate on demand this VMware-based virtual machine, in this case, into, for example, an EC2 instance in the public cloud. And then you can temporarily use this to test new versions of an application, for example. Maybe you don't have enough space in your SDDC at the moment. And then if you don't need it anymore, you simply throw that instance away.
That's really cool. Okay, Philip, so we talked about cloud, we talked about the integration with VMware. The thing that kind of wonders me is that you already talked about SLAs in this video and as well as the previous one. If you have a software-defined data center, you know, every VM could be a different one. Every VM requested by, for instance, a developer or by the business in general could have a different SLA. So how would that work from a software-defined data center perspective?
Right, so typically what we can do is we try to automatically assign SLAs as much as possible. So the way that looks like is if you define an SLA in Rubrik, you have to decide the location where that SLA is valid. So for example, what we can do is we can assign an SLA on the vCenter level, or we can assign an SLA on the virtual folder level, on the cluster, on the host, on an individual virtual machine, or we can even use vSphere tags to assign SLAs.
Okay.
So the idea would be, depending on where this new virtual machine that, for example, you're deploying via vRealize automation, or a complete set of virtual machines that you're deploying via VRA, depending on where it lands in this system, so maybe it's on the cluster, wherever it appears, and if there's an SLA assigned to this object, then those new virtual machines that you're just adding through VRA, they will inherit this SLA. Alternatively, what you can do is, from a workflow within VRO, of course we can override the SLA assignment. So even though you're saying, okay, it's going to land on this cluster and this cluster has an SLA, we can say through VRA, we can say, okay, but these particular 3 virtual machines, they should get, for example, the bronze SLA in this case.
Right, and from a VRA, vRealize orchestration workflow, we could just add the SLA as an object.
Right.
Right,
Yep.
okay.
Yep.
That's really cool.
And then the tagging piece is more of, so there's typically a backup administrator managing this Rubrik system. But the idea would be that if you consume services in an SDDC fashion, as a developer, for example, you don't necessarily want to be reliant upon a backup administrator or an infrastructure administrator to help you out in terms of protecting your data.
Yeah.
So what we came up with is this idea of tags, where you simply say through vSphere or through vCenter, you assign a tag to a new virtual machine. So let's say you deploy a new VM, and first it's a test VM. So you assign the tag test to this virtual machine. In our system, we can then say, okay, the test virtual machine doesn't actually get an SLA because we're not really interested in protecting that data. If you promote this test virtual machine maybe into production, let's say, by changing the tag, then we will automatically pick up on that and maybe add it to the silver SLA inside of Rubrik. So as a developer, you don't really have to think about what does the protection aspect of my system look like. It's just part of the automated stack end to end.
That's really awesome, and I think it covers the integration between or the automation part of the software-defined data center as well.
Yeah, absolutely.
Okay, so the thing you covered is already that you have a near zero RTO. So what about the RPO?
Right, so historically speaking, we've always been based on VMware snapshots, and those snapshots are triggered by our SLAs.
Yeah.
So the internal algorithm sort of determines when is the best time to trigger a snapshot. And the way that we do that is we actually query vCenter. So we use telemetry information from vCenter, which tells us what is the CPU load on a particular host, what is the I/O latency on a particular data store. So taking that into account, we can sort of shift the schedule that we've built internally to make sure that we're not causing harm to production. That's always the first thing, is never cause harm to production. Having said that, our smallest RPO window historically was 1 hour. So through our scheduler, we could schedule a snapshot each hour. And because we're doing incremental data, the amount of data that you then have to transfer would be minimized. Of course, there's also workloads who need a smaller RPO, preferably an RPO of near zero as well. So what we came up with is we worked with VMware and we developed a filter driver for the VIO stack.
Really?
So we're now moving into this territory of continuous data protection, which will give you a, let's say, a near zero RPO as well. So the concept is through a filter driver that we developed, which is installed on the ESXi host layer. And then you use storage policies to then enable or disable this filter driver for a specific virtual machine.
That's cool.
This happens through our interface, by the way. So in the interface, if you, within the same SLA concept that we have, decide to use continuous data protection, then we will enable that filter driver for that specific virtual machine that you want to do CDP for.
Wow. So basically set a tag to a VM or to a group of VMs, configure an SLA to use that tag, and in the SLA you'll just mention an RPO of near zero.
Yeah, absolutely. Yeah. So the idea then is that each and every I/O that goes through the storage stack, while being written to, let's say, an NFS data store or whatever data store that sits beneath it, will also be replicated to our CDM cluster as well. So now you won't lose any I/O in a production environment. So now we give you the possibility then to do application-aware restores by using snapshot technology, together with the latest I/O, getting the latest I/O back through CDP. So you sort of have the best of both worlds.
This is really awesome.
I
Cool.
agree.
Yeah. Okay. Well, Philip, thanks again for explaining everything to us. Thank you so much for watching, and we'll see you next time.